download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about fuel cells and it is a triple only video. Now in a fuel cell, a fuel and oxygen are supplied from external sources and the fuel is oxidized and a voltage is produced. So before I go into it, let me quickly remind you of oil rig, which is something you were introduced to in a previous video. It stands for oxidation is loss and reduction is gain, and it means in terms of electrons. So oxidation is the loss of electrons and reduction is the gain of electrons, and that's important to understand for to get your head around what a fuel cell is. Now what happens in a fuel cell is that fuel enters, whatever fuel is being used enters at one side where it becomes oxidized, i.e. it loses electrons. Okay, so if fuel enters at one side here and that fuel is going to be oxidized, that means that fuel is going to lose electrons. Okay, now what that does is it sets up a potential difference of a voltage within the cell, and it's this potential difference that powers the device and whatever it is you're using. So this is why we can use it in replacement for batteries. Now the oxygen enters at the other side. Okay, so oxygen enters at this side. So remember, we're using a fuel and oxygen, so fuel and oxygen. Oxygen is going to enter at the other side, and it reacts with the fuel to form water, and the water is going to leave the fuel cell here, so water and energy out. Okay, so the fuel is going to enter here, it's going to be oxidized, the electrons are going to pass through the circuit. Now that oxygen is of course going to react, as I said, to the fuel and the electrons to form water, and that is going to leave through here. Now there are a few different types of fuel cells and using different fuels and different electrolytes, and the electrolyte in this example is here. So this is where we put the electrolyte, and we do need to learn about the example of a hydrogen oxygen fuel cell, and I'm going to teach you about that now. So let's run through then an example of a hydrogen oxygen fuel cell and see how it works. Now in a hydrogen fuel cell, or hydrogen oxygen fuel cell, hydrogen and oxygen react to form water. So in this example, the fuel is hydrogen. And because of that, hydrogen is getting oxidized, i.e. it's losing electrons. The oxygen will come in and react with the hydrogen and it will form water. Now why this is important, why this is useful, and we'll talk about this in more detail in a second, is that water is not polluting. It releases energy and it is not polluting. So let's talk you through then what happens. So hydrogen is fed into the negative electrode. Okay, now the negative electrode is the anode. Okay, so the negative electrode, or the anode, which is here. Okay, now don't get this confused with electrolysis, because in electrolysis the anode is positive and the cathode is negative, and in cells it's the other way around. And that is a bit confusing, but just remember that in fuel cells it's the other way around. So the anode is actually negative and the cathode is actually positive. So as we said, hydrogen is fed in at the negative electrode, which is the anode, and that happens here. And we're going to feed that hydrogen in here. Now as we said, that hydrogen is going to be oxidized, which means it's going to lose electrons. So these electrons are going to be here. So it's lost the electrons. The hydrogen has lost those electrons. Now because these hydrogen atoms have lost electrons, they've become H+ ions. Okay, you'll remember from a previous video that an ion is something that has lost or gained an electron. And if it is a positive ion, that means it has lost electrons. In this case, the hydrogen has lost electrons, therefore it's become a H+ ion. And these H+ ions move through the solution. okay, or the electrolyte. Now, the electrolyte in hydrogen oxygen fuel cells is usually potassium hydroxide. Okay, so that's usually the electrolyte for hydrogen oxygen fuel cells. Now, what happens now is that these electrons can flow through the circuit to the positive electrode. So this here is the positive electrode, and we call that the cathode. So these electrons are flowing through the circuit to the positive electrode. Because they're negatively charged, they're going to be attracted to the positive electrode, and therefore they are going to move to the positive electrode. Now, what happens at the positive electrode is in here, oxygen is fed into the cathode, or the positive electrode. Okay, so oxygen is fed in here. So here we're going to have this oxygen. Okay, so oxygen is fed in. Now, at this positive electrode, oxygen is going to gain the electrons that are flowing from the hydrogen. So here the electrons are flowing, and the oxygen, the O2, is going to gain those electrons. And as well as gaining those electrons, it's going to attract to the H+ ions to form water. So let me just explain that a little bit simpler. Okay, so if the oxygen gains electrons, then as we know, it's going to become negatively charged ion, because it has gained a negatively charged electron. So the ion that it creates is of course going to be O2 negative, okay, because it's going to have gained the electrons. Now, this water that has been produced by reacting the hydrogen and the oxygen together will then leave the fuel cell, and also energy will leave as well. So this is where water and energy leave. And that's these electrons that are flowing through here that create that electric current that we can use for whatever it is that we're trying to power. So this electric current here, for the flow of electrons that is being created here, is useful to us to use for whatever it is that we need the power for. So this explains a hydrogen-oxygen fuel cell. Now, you do also need to be able to write the half equation for the reactions happening at each electrode in a hydrogen fuel cell, but this is for higher only. But before I do that, let me just sum up what went down in the this part here. So at the negative electrode, which is here, we call it the anode, the hydrogen loses electrons to produce H+ ions, and we call this oxidation. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. Okay, so at the negative electrode, which we call the anode, hydrogen loses electrons to become H+ ions, and remember this is oxidation. Now at the positive electrode, and remember now we call that the cathode, which again is opposite to electrolysis. Okay, oxygen gains electrons, so it gains those electrons that are lost from the hydrogen. So it gains the electrons from the cathode and reacts with the H+ ions to form water, and we call this reduction. Okay, so hydrogen is oxidized and oxygen is reduced. Okay, now that helps us then to put together these half equations. So at the anode, we'll do it the anode first, which is here. We said that hydrogen loses electrons to become H plus ions. So we're going to have hydrogen is going to lose electrons. So we know that an electron is going to be lost. An electron is a negative. And it's also going to form H plus ions. Okay, now hydrogen always exists in pairs, so we do need to write H2 there. Therefore, it formed 2 H plus ions, and therefore it will release 2 electrons. And that is our half equation at the anode. So hydrogen loses 2 electrons and becomes H plus ions. So you have to remember that, of course, for at the anode. Now at the cathode, which is a little bit more complicating, but not too much complicating, the oxygen, okay, so the oxygen, which is of course O2, reacts with the H plus ions. Okay, so the oxygen reacts with the H plus ions. Now each oxygen, you'll remember from a previous video, needs 2 electrons, and therefore will react with 2 hydrogens. Remember H2O, so it's going to be 2. But if there's 2 oxygen, then we're going to need 4 H plus ions, because they each need 2 each. And, as we say, they're also going to react with 4 electrons. And this forms H2O. But of course, this isn't balanced, and to make this balanced, we need to just add a 2 in front of here. And that is our half equation at the cathode. O2 plus 4H plus 4E minus produces 2H2O. And this bit here is a nice little summary. And then just to add to that, it's the electrons that flow that gives the electric current, which of course is, as I said earlier, we can use to power whatever it is we're trying to power. Now fuel cells can be used instead of rechargeable batteries, as there are many positives to using them. However, there are also some disadvantages to using fuel cells instead of batteries, and you do need to be able to compare the use of hydrogen fuel cells with the use of rechargeable batteries and cells by outlining the advantages and disadvantages. So let's talk about them now. Okay, so the advantages, and we're going to be talking about fuel cells. So the advantages of using fuel cells is that they, as we said earlier, don't produce pollutants. The hydrogen-oxygen fuel cell produces water, which is not a pollutant. And this is obviously a big benefit, especially on rechargeable batteries and other fuel, which do produce lots of greenhouse gases, carbon dioxide, carbon monoxide, for example, which are not good for the environment. Another thing is that actually batteries are rechargeable, but there is a limit to how many times they can be recharged. In fuel cells, however, there is no limit to how often. Okay, so no limit, whereas in batteries there is a limit to how many times they can be recharged before replacing. And actually batteries also store less energy. So fuel cells store more energy. And therefore they don't have to be recharged as often, okay, because they can store more energy at a given time. As I did say, however, there are also some disadvantages of using fuel cells that you do need to be aware about. And one is that because hydrogen is a gas, it takes up lots of storage space. Okay, much more so than a rechargeable battery. So it takes up a lot of storage space. Again, more so than a rechargeable battery. Again, hydrogen is actually explosive. Okay, so hydrogen is explosive. And because of that, it makes it hard to store. Okay, so hydrogen is explosive when mixed with air, so it's actually quite hard to store safely. And finally, to produce hydrogen and hydrogen fuel, which often comes from hydrocarbons, which are fossil fuels, or electrolysis, which uses electricity. Okay, and this electricity and getting this electricity actually does produce pollutants. Okay, so getting the hydrogen in the first place comes from doing things that require electricity, and therefore some pollutants have going to be formed to get that electricity. Okay, so it's made from hydrocarbons or electrolysis. So as you can see, there are lots of advantages and disadvantages to using fuel cells, and you do need to know these, so make sure you do remember these. So here we have some summary questions for you to have a go answering to test your understanding on this quite difficult topic. So pause the video now to have a go. Okay, so what is a fuel cell for number one? Well, a fuel cell is where a fuel and oxygen are supplied from external sources. The fuel is oxidized and therefore a potential difference or an electric current is produced. Okay, so if fuel and oxygen are supplied from external sources, the fuel is oxidized and a potential difference or electric current is produced. For question 2, what is the fuel in hydrogen-oxygen fuel cell? It's hydrogen. And for question 3, what is oxidized in a hydrogen-oxygen fuel cell? Again, it's hydrogen. So remember, in a fuel cell, the fuel is oxidized. So because the fuel is hydrogen, hydrogen is also oxidized. What electrolyte is often used in hydrogen fuel cells? It's potassium hydroxide. Write the half equation at the anode for a hydrogen-oxygen fuel cell. So you should have, of course, written this. It's also a good idea to practice the half equation at the cathode. Give one advantage to a hydrogen fuel cell over batteries. Well, one, you could have said that they don't produce pollutants. You could have said that batteries are more expensive. You could have said there is a limit on how many times you can recharge a battery, but not a fuel cell. And for the question 7, one disadvantage to hydrogen fuel cells, you could have said that hydrogen takes up space. You could also say it's explosive and therefore hard to store. And you can also say that hydrogen must be obtained from hydrocarbons or electrolysis, which uses electricity. So you've there looked at fuel cells and more specifically a hydrogen-oxygen fuel cell. There were many practice questions for you to have a go at on the website, and as ever, if there's anything you didn't quite understand, then please do get into contact with one of our tutors who will happily help.